Today, we'll be solving LeetCode 1448, Count Good Nodes in Binary Tree. This problem gives us a binary tree, and we have to figure out how many nodes are considered good. A node is good if, from the root to that node, there is no node with a value greater than it. In other words, as we travel from the root down to this node, it must always be at least as large as every node we have seen so far. Let's think about this. Since we are dealing with a tree and a path from root to node, we need to carry the information about the maximum value we have seen so far along the path. As we move down the tree, if the current node's value is greater than or equal to that maximum, we count it as a good node. We also update the maximum for the rest of the path going down. The main pattern here is depth-first search, often called DFS, because we need to explore each branch of the tree while keeping track of the maximum value seen so far. The data structure we are working with is a binary tree, and we'll traverse it recursively. Now, let's walk through the code step by step. We start by defining our function called goodNodes, which takes root as input. This root is the starting point of our binary tree. Inside this function, we create another function named DFS, short for depth-first search. This helper function will take two arguments, the current node, and the maximum value we have seen so far on the path. In our DFS function, the very first thing we do is check if the current node is none, meaning it does not exist. If so, we simply return 0, because there are no good nodes to count here. Next, we create a variable named total and set it to 0. This variable will keep track of how many good nodes we find in this part of the tree. We then check if the current node's value is greater than or equal to the maximum value we have seen so far. If it is, that means this node is a good node. In that case, we increase total by 1. After that, we calculate the new maximum for the path going forward. This will be the greater value between our current maximum and the current node's value. Now comes the recursion. We call DFS on the left child of the current node, passing in this updated maximum value. We also call DFS on the right child of the current node, again passing the updated maximum. Each call will return the number of good nodes found in that subtree, and we add them to total. Finally, we return total, which now contains the number of good nodes found starting from this node. Back in our main goodNodes function, we simply return the result of calling DFS on the root node, with the initial maximum set to the root's value. This makes sense because, at the start, the largest value we have seen so far is the root's value itself. In terms of time complexity, this is O of n, where n is the number of nodes in the tree, because we visit each node exactly once. The space complexity is O of h, where h is the height of the tree, due to the recursion stack. And that's how you solve LeetCode 1448. Thank you for watching, and let's keep learning.